In this first question, we are trying to solve for the number of subatomic particles in various atoms and ions. For the first problem, we're looking for the number of subatomic particles, or the number of electrons, protons, and neutrons. We'll start by looking at an atom of technetium. By going up to our periodic table, we find this is element number 43. In addition to that, we find its molecular weight of 99. So for a neutral atom, the number of protons and the number of electrons are both going to be equal. To the atomic number of 43. The number of neutrons we can calculate from the mass of the atom, which we see as 99, and subtract out the number of protons of 43 to get to the final number of neutrons of 56. Part B looks at francium, but we're not just looking at francium here, we're looking at an ion, specifically a +1 ion. So again, we want to go up to our periodic table. We find francium, element 87, with a mass of 223. So we know that our number of protons is equal to the atomic number of 87, and the number of neutrons is equal to the mass of 223, minus the number of protons, which is 87, and that gives us 136 neutrons. The electrons here are what change. Anytime we have a charge in a molecule, we'll end up with a different number of electrons. Francium normally has 87 electrons, but since it has a positive charge here, that tells us it has one less electron. So we find a total of 86 electrons. Part C looks at bromine. Bromine we find over here with an atomic number of 35. It has an atomic number of 35. We know that there are 35 protons. Since it's neutral, we know that there are also 35 electrons. Now the mass of bromine on the periodic table is 79.9. But here, as the problem specifies, we're looking at an isotope of bromine, specifically an isotope with mass of 81. So here we take the mass of 81 of this specific isotope, subtract out the number of protons, and find 46 total neutrons.